We're live? Okay. Yep. Hello, everyone. Hello. And first of all, a big thank you, because we never had these numbers. We never had such a full room. So thank you very much for coming tonight. And perhaps it might be the day, it might be Monday, right? So welcome to the meetup. Tonight, my friend Antonio is going to talk about cloud-native CI/CD with GitOps, which I can see it's a fairly popular topic. Great to hear that. Just a couple of things. I'll be out of my way, on my way out in a minute. But first of all, code of conduct, as usual. It's inspired by the conference codeofconduct.com. It's very much down to be a decent human being. If you have a problem or you experience anything wrong, come to me, talk to me, and we'll sort it out. But I'm sure that everyone is able to have, exactly, to behave like a decent human being, like a decent person. Emergency exits in case of fire. One over there on the right, just behind the corner, and the main one down at the bottom. Nothing else really to add on the emergency exit. April, we don't have anything planned yet, but I'm looking for a speaker. If you want this stage, come and talk to me. Happy to give you the stage, all right? I'm always happy to have anybody new on a stage, and also I would like to remind you about our mentoring program, where if you're a first-time speaker, come and approach us, Tarun and myself, and we can have a word. We can guide you through to your first speech or your second speech or third or whatever. If you want to talk to us, feel free to do so. But at the same time, we already have a venue booked for Global DevOps Bootcamp. So Saturday, 30th of May 2020, we'll have the bootcamp again here in London. Registration will open very shortly. They're not going to be done on meetup.com, but there's going to be an Eventbrite registration page like last year where you can go and register yourself for the bootcamp. It's going to be a whole day. It's going to be a Saturday. And this year we will also have food compared to last year. So try to make it more appealing to you guys, but we'll try to get food. So we secure some sponsorship to get it. So yeah, registration will open, so keep an eye on the meetup as usual, and you will be definitely notified. I'm done. I'll leave the stage to Antonio. He's an old friend of mine from Italy. He's going to talk about cloud-native CI/CD with GitOps, which I think it's something that people are interested in hearing real stories about, or even just to hear about how to do that. Because our industry is full of buzzwords, unfortunately, and it's always good to put down some demos or some explanation towards the buzzword of the moment. So I'll leave the stage to Antonio. Thank you very much.
Thank you. How are you doing? Let me just... Okay. So, the last 10 years have been exceptional for the software development world. You can agree with me that the rise of cloud technologies and the introduction of DevOps have changed how we, as developers, create, deploy, and of course, test our application. Indeed, in the DevOps world, there are so many tools, frameworks, practices, that sometimes it's challenging to find the right tool for your problem. Today, I'm going to explain how you can simplify your development process, talking about GitOps and a limited number of tools that you can use to improve your process. I want to thank, first of all, Matteo for the hospitality. I want to thank you for being here. Full disclosure, I'm Italian, so this means that I will move my hands a lot. And of course, my English won't be perfect, but I hope you will enjoy the content of this session.
And you will be on every other month basis, so
Okay. Okay. It's working? Yeah. Let's start with the agenda. I will give you a definition of GitOps. I will try to explain what are the differences between DevOps and GitOps. And then I will explain to you GitOps principle, tools, and best practices. So let's start with a definition. GitOps is a term coined at Weaveworks. Funny thing, Weaveworks, it's at the end of this street. I'm curious, anyone from Weaveworks here? Oh, okay, that's cool. Well, GitOps is just a way to do continuous delivery. It is mainly based on Git. And Git is considered as the source of truth of your application. Inside your repository, you will have both the application and the infrastructure declaration. You will have something that will automate deploy. And each time you make a change to your repository, a deploy will be triggered. And then your infrastructure, your system will be updated. Let's see a few principles. So the entire system is described in a way, in some way, in a declarative way. You can use tools such as Terraform, or if you are using Kubernetes, you can use YAML files. And in these files, you will store the desired state of your infrastructure. All these files are versioned in Git, so you will have an history of the change that you made to your infrastructure. Each time you need to do a change, this change should be approved. You can use, for example, pull request mechanism. And after that, when your code is merged to the target branch, there will be a pipeline that will start and will update your infrastructure and your system. Also, you must have some sort of services, such as monitoring services, to alert you when the desired state of your application diverged from the actual state of your application. So you may take action to converge the state back again to your desired state. So having it as a single source of truth means that each time you make a change will be triggered a new pipeline. As I said before, both the application and the infrastructure declaration are inside Git. This means that tools such as kubectl are not suggested to use because you are breaking the rules. You are doing something that is not versioned or not traced anywhere. And in this case, with GitOps, you have your infrastructure declaration that acts as the documentation of your system. And once you have prepared the infrastructure declaration, you need to approve these changes using a pull request. And the entire process is automated. So GitOps in a sentence, only what you can describe, for example, with a declarative manner, such as Terraform, and what you can observe with some sort of monitoring tool can be automated and, of course, controlled in case of divergence. And if the whole process is automated, then you can accelerate your software development process. What are the differences between GitOps and DevOps? GitOps is based on DevOps. It shares the same principle, the same culture, the same tools and practices. For example, GitOps want you to automate the deployment, so you have continuous delivery. continuous deployment, you can have monitoring, you have feedback loop. And the reason why just now we are talking about GitOps is because before a few years ago, there wasn't tools that allow us to store infrastructure declaration in a simple way. And of course, you can use Git because Git is the tool today mostly used in the developer world. And it will store your code, it will version your infrastructure in a simple way. What are the advantages? Of course, you have increased the productivity because the mean time to development will be lower. You have a better developer experience because GitOps is developer-centric. And developers can use their knowledge that already have to do GitOps. Of course, you want to deploy the code. You want to version the code of your system, not the image. So the learning curve of a new developer in your team is really low because usually we already know Git, we know how to use it. We have a compliance and stability thanks to audit because each time we make a change in Git, Git will version the change, and this is audit. In some countries, such as the United States, you must be compliant with some sort of requirements, such as COC2. Also, you have reliability. This is what fascinates me about GitOps. You can recover your system from a meltdown just doing another deployment because the whole infrastructure is inside your repository. Consistency, because your workflow is pretty simple, and you have a standardization of the entire workflow using GitOps, using Git. And finally, security, because Git has out of the box some security mechanism, such as SSL or HTTPS certificates. And also you can have signed commits using PGP encryption. And another thing about security is that the information related to your infrastructure are not stored inside the Git repository, but will be stored in other tools that help you to do configuration of the system. What are the three GitOps pillars? We have, first of all, pipeline, then observability, and then control. Let's start with the pipeline. We have essentially two kinds of approach. The first one is a push-based approach, where you just write the code. Your code will be tested, then compiled, tested, and then will be created an image if you are using Kubernetes. And this image will be deployed on the Kubernetes cluster. This means that you have a continuous integration pipeline, and then you will have a continuous deployment pipeline that will take the image, will pull the image from the image container registry, and will apply this image on the Kubernetes cluster. So the application repository is updated with some change to your code. This will trigger a build pipeline. The build pipeline will update the image registry. And finally, you will have also an update of your environment repository. From this point on, you will trigger a deployment pipeline that will update the environment, for example, a Kubernetes cluster. The other approach is the pool-based approach. And this approach is the approach really suggested from GitOps, from the GitOps culture. Because, first of all, you have a new element in the pipeline, and this element is named as operator. The operator will make sure that the actual state of your system is equal to the desired state inside your repository. And to do that, it will check once in a while the differences between the actual state and the desired state. If there is any difference, it will start a new deploy to update your system. This is an interesting approach because if I go back for a second, when you have a problem on your environment, if you don't have a monitoring tool, your pipeline, your code don't know what happened. In the pool-based approach, the operator takes care of everything. So this means that if you have a problem, the operator will take care to bring your system up again. Also, from a security standpoint, the only element that has access to your system is the operator. And usually, the operator will live inside the Kubernetes cluster, for example. So you don't have to share sensitive information, and the operator needs only the access to the repository. If we are using, for example, Azure DevOps, you can have a rollback access configuration. From a technical standpoint, what you will have is that when your application repository is updated, it will trigger a build pipeline. The build pipeline will build the image for your container and maybe can update your environment repository. If not, the operator will take care of that. And the operator will observe the image registry and the environment repository. If there is any change from the actual state and the desired state, it will trigger a new deployment. The same approach, you can use the same approach if you have multiple environments. And these can be achieved using your deployment system. For example, if you use Azure DevOps, you can have multiple environments related to your infrastructure, and you can put in place some configuration to do one deployment instead of another related to the environment that you need to update. The second pillar is observability. Today, it's very hard to find a problem in your system if you don't have observability. If you don't have a log, if you don't have traces, you can know what happened into your system. So this is a tweet from John Arundel, and he started this thread that is observability-driven development. That is, never accept a pull request if you don't have a way to verify that it does what it's supposed to do. So this is a good rule. How you can achieve observability? You must have logs, metrics, and traces. There are lots of tools that help you to do that, to collect metrics, logs. We will see some of them after. Final pillar is control that works closely with observability, because when the state of your system diverges, control takes care of converge your state to the desired state. So controls means convergence. How you can achieve that? Using, for example, the operator. After an alert from the observability tool, you can trigger, thanks to the operator, you can trigger a new deployment. So you can update the actual state of your system, matching the desired state. So Git is at the center of everything. You can have continuous integration to build the image. Then you can have something else related to your system, for example, Kubernetes, to do deployments, observability, and of course, management. How should I structure my repository? Well, the repository needs to have essentially both the application and the infrastructure declaration. If you are using Kubernetes, you must have, for example, YAML files that do deployments and services. If your system is more complex, you can have some infrastructure layer. For example, if you need to have an Azure SQL database or, I don't know, new resource groups, and so on, you can store in the same repository also the infrastructure layer, so the information about the infrastructure. Sometimes you can store these three things into two separate repositories. So you can have one repository for the application layer and the Kubernetes layer, and another repository only for the infrastructure layer. This really depends on which deployment pipeline or which tools you use to do continuous deployment. For example, if you use Azure DevOps, you can store everything inside one repository because you can apply on the pipeline something named the filter path that will not trigger the pipeline related to your infrastructure if there aren't changes related to your infrastructure. And the filter is based on the path of your configuration file. So, to sum up, one repository per application, eventually one repository for your environment configuration. Branches are usually mapped to the environments. This means that if I have the dev environment or if I have the test environment, in my repository I should have the dev branch and the test branch. Changes are related both to the application code and also to the infrastructure. This is what I like of GitOps. If you have a problem, you can always do a revert. It's a simple operation in Git. It will create a new commit, changing your history and going back. So this will save you in case of a meltdown. And it's really simple to do it. And you can use protected branches to force the pull request mechanism by the developers. OK. Let's move to the demo. I have for you 3 different demos. The first one is based on the push approach. I will use for this demo Azure DevOps. The host environment is a Kubernetes cluster on Azure. Let's see the code. This is an application named MHS. It's from the Azure Dev Test Lab. You can download it, you can test it. And it has some files related to Kubernetes, a YAML file, in which you will find the deployment and the services. How can I deploy this application? I have a pipeline. Oops. Let's see the pipeline. The pipeline is composed by a build part and a release part. In the build part, I will update some YAML files, replacing some tokens. These tokens are inside the app settings JSON file. After that, I will start to create the Docker image for my application. The Docker, yeah. Okay. The Docker image will be pushed to Docker, or can be pushed to Docker, but in this case, will be pushed to Azure Container Registry. And my application will have two artifacts that are a YAML file and a DuckPack file. Once I have run this build, I will find in my Azure Container Registry inside the repository the image. This image will be pulled in the release pipeline and will applied to the Kubernetes cluster. So let's see also the release part. Okay, this is my artifact. The artifact is created by the build part. When a new artifact is created, it will start a new deployment. The deployment will update a SQL Server database, and then will apply the new image on the Kubernetes cluster. Once I have built this pipeline, the entire pipeline, I can do a test of my application. I will open one. Okay. This is how I created a Kubernetes cluster. It's just a bunch of commands using Azure CLI. At the end, I can check the status of my application. Okay, I have to change this one. Okay. Okay. I will get the pods in my Kubernetes cluster. The application is composed by two pods, back and front. I can see if my application is OK, taking the IP address using kubectl. and this is my app deployed. So this is the first approach. In this case, I have a pipeline that doesn't know anything about the status of my application. The second approach I want to show you is related to the pull approach. And in Azure DevOps, you can take leverage of something named environments to create a link to your environments inside your build pipeline. Okay. I'm going to show you how you can structure your repository using GitOps, and then I will create a release pipeline for my application. So let's see first the repository. Okay. I am importing this repository that is just a template that I use for the demo. I'm importing it from GitHub. This is an ASP.NET application, ASP.NET Core application. So I have my repository here. The first step I have to do, if I use GitOps, is to change the branches to match my environments. For example, if I have 3 environments, such as production, I have to create 3 different branches. So I have created production. I will create test branch, and then dev branch. I have to make sure that no one can do a change to these branches if there is I have to make sure that no one can make a change to these branches. So I have to create a branch policy which help me to create pull request on the branch when someone have to merge their changes. So this means that I have to go here. First, I will delete the master branch. I don't need it anymore. Then I have to set some branch policies. I will set check for comment resolution for each branch. So when a developer wants to modify something, he needs to create a pull request to apply the change to the target branch. Okay, oops. Okay. Now I can create my release pipeline. If I go into pipeline section of Azure DevOps, I can create a new pipeline. I have to set the Git repository of my code. Oops. Why all project? It's the repository. I can find the repository. Okay, let's try with a. Okay, we'll try another thing, set up a build. Okay, so it's really beautiful, something that Azure DevOps do for me. I have just to say which is the deployment environment. In this case, I have an Azure Kubernetes cluster. I can click on deploy to Azure Kubernetes service. It will pop up a page where I can select my subscription. I can select the AKS. Okay. Right. Okay. Let's give it a moment. Okay. And after that, I can select the cluster. Right now, I have 3 clusters. I can select the namespace. Usually, you can match the namespace on Kubernetes, like the name of the branch. I usually do that. So I can create a new namespace. This is for, if I'm not mistaken. I suppose that this is the production branch. So I will make here production. Oh, let's do that. Let's check before. Yeah. So I will do that again. Once you have set all the namespace, you have in the environment section a link to your cluster. And inside the link of your cluster, you will have the resources that are the namespaces. So let's try that again. Okay, so this is the cluster. I create a new namespace. I need to have also a container registry. I already have one. And after these settings, a new release pipeline will be created by Azure DevOps, and also a new environment will be created. Let's give it a moment. The interesting thing is that Azure DevOps just read my Git repository, and they will create for me the entire pipeline. So I have a build part, the build stage, in which the build will create and push my Docker image. And then I will have a deploy part where the changes are applied to my environment. And talking about environment, if I will save this pipeline, I will create a new branch because the dev branch is protected. If I go to the environments, now I can find a new environment. This is a link to my Kubernetes cluster. And I have a resource that is the namespace where I want to deploy my application, the namespace on the Kubernetes cluster. Another thing can happen. If I go back to the pipeline, I have the master trigger, but my branch is named dev. And also, I can reuse this pipeline because I can set the trigger on multiple branches. Oops. There is one thing that I have to fix, and is the environment name. Because here, I have the environment name set inside the build pipeline, and it is dev. I have to generalize this information. I can do that using the environments in Azure DevOps. I can use build source branch name. This means that I don't need more than one pipeline definition. I can reuse this definition. And then each time the pipeline will run, it will take the source branch name and will apply the changes on the correct environment. OK. I can start the pipeline. To start the pipeline, I have to merge my pull request to the dev branch. So I'm going to do that. OK, I will take this one. OK, this is happening. Let me see the commits. OK. So I will approve and complete the pull request. You shouldn't do that because another person on your team should do that. When I have completed the pull request, a new pipeline is triggered. So I will have two stages, the build stage and the deploy stage. In the first phase, Azure DevOps will build and push my image. Then it will deploy the image to the cluster. Let's suppose for a second that I want to bring this change to the test environment. I have to do another pull request between the dev and the test branch. Right now, I don't have a resource for the test branch, so I will make one. Again, this is just a namespace on the Kubernetes cluster. Yeah. Thank you. Let's go back. OK. Okay. In the meantime, let's see the pipeline. Okay. Okay. The build phase has been completed. The artifact of my build phase are two files, two YAML files. Let's see for a second the repository. I have my application, and I have a folder named manifests which contains the deployments and service related to Kubernetes. In these files, I have just the information that Kubernetes needs to have to deploy my pods. And my build phase will have these two files as artifacts because it's a new configuration. The image has been uploaded on the Azure Container Registry. Then there is a deploy phase where the artifacts are downloaded, and the deploy to the Kubernetes cluster has been applied. This deployment is applied using kubectl. And what's interesting is that if I go into the environment section on the dev namespace, I will have a few information about the deployment, the workloads, the services. This is the external IP that I can use to see the application. If I click here, I can get detail about the pods that is running on the Kubernetes cluster. Let's see if it works. Okay, I will copy that here. And this is my ASP.NET application deployed. Here I have a few checks about the deployment. This is not a real-time check, which means that this is not a monitoring tool. It will just say if the deployment is completed correctly. And I must have some other monitoring tool to check the status of my pod. If I use Kubernetes, I can use, for example, Prometheus and Grafana. I have configured the Grafana on this cluster. Let's see the status of the pods. Okay. I will get the password to access to the dashboard. Then I will get the pod name related to Grafana, and then I will do the port forwarding to access to the Grafana dashboard. You can easily configure Grafana on your Kubernetes cluster using Helm. It's taking some time. Okay, let's try that again. Okay, that's okay. Now I will have the pod name. Okay, perfect. If I open the browser, I go to localhost 3000. Okay, it's already logged. I have few dashboards already installed. Grafana is very simple to use. You can import a new dashboard from the dashboard repository. And then you can see that dashboard in this way. You can filter on the pod. You can filter on the namespaces. For example, this is the namespace I have just deployed. There are different, dashboard here. Let's see another one. I have a dashboard about Kubernetes cluster, which will give me all the information about the cluster. So pods, memory, CPU. And under the Grafana, there is Prometheus. Prometheus is just a time series database that will collect all the information about Kubernetes. Kubernetes has out-of-box a metrics server which collects all the information. And with the Prometheus, you can also set some sort of alerts. Another way that you can monitor your Kubernetes cluster is using Azure, Microsoft Azure. Let's see the Azure portal. You can use something named Azure Monitor for Containers. And you can have live stream data. This is my cluster. If I go into Insights, I can see all the information related to my cluster. I have many sections where I can get the information I need. And I can view live data. So these are all the logs related to my cluster. For example, I can see here I have a problem about a pod. And of course, I can use metrics to do query and to improve the way I'm collecting information. So in this way, we can do monitoring of our Kubernetes cluster. And we can understand if there is any case of divergence between the desired state into my repository and the actual state on the cluster. Any question? OK.
This thing is actually insights, right?
Yeah, that's insights. And you have to enable Azure Monitor for Container. And if you want to see the live data, you have to do a log reader role access. You can find this snippet on the website on the Microsoft website. And these just allow the Azure container monitoring for containers to access to your cluster. OK. So the last example that I want to show you is related to the concept of the operator inside the Kubernetes. Because until now, we have not seen the operator yet. And with the Kubernetes, there is a concept that is operator, which help you to understand what is on the cluster and act in some way on your cluster. So you can apply something, for example, a new configuration using the operator. It's just something that you do in a programmability way. Usually you can write your operator in Go. And there are few operators, for example, the Flux operator, that you can use to do continuous deployment of your configurations and also your application in a simple way. The example that I want to show you today is related to Argo CD. Argo CD is a tool that is essentially an operator. It will be installed inside your Kubernetes cluster, and will check if the desired state is equal to the actual state. Before I show you that, I want to introduce the tool Customize. Customize is a tool that you can use with the Kubernetes to apply configuration of your cluster depending on the environment you want to update. For example, if you have a configuration like the two YAML files that we have already seen, deployment and service, you can customize these files, creating overlays for your environment without changing the two original files. So you can create a customization of your environment with the Customize, and then apply that customization to your environment. Let's see how we can do that. First, you have to install Customize on your machine. Customize is fully integrated in Kubernetes in kubectl, because if you do apply -k, you can use a Customize file to apply a configuration. I will download this repository. It's the same repository as before, but I have a customized file. Oops. Okay. So I have a customized file. This is just a file of customization. Yeah. Thank you. It's okay? Okay. So I have a link to the files, and from now on I can apply a new customization to these files without changing them. First of all, if I build this folder with the Customize, I will have the entire YAML file to apply to my Kubernetes cluster. So I will have the service part and the deployment part. If I want to create a new environment, I can create a folder. Okay. Then I can add a variant to my files. Let's see what I've done. So I have just created an overlays. This overlays has a dev folder. Inside there is a customization file. This customization file has just few information and the name of the environment. In this case, the name prefix. Then I can build this environment. This is the new YAML configuration that I need to apply to my Kubernetes cluster. I can push this new information to my repository. And once I've done that, I'm ready to use Argo CD to have automation of my deployment. So first of all, I will create a new instance of Argo CD. Argo CD will be just deployed inside my Kubernetes cluster. I have to change the cluster in this way. OK. Then I have to install it. If you want to use the Argo CD CLI, you can install it using a Brew or other tools if you are using Windows. Then I have just to run Argo CD to do the port forward. And I can open Argo CD to configure the repository that I have to observe. Remember, this is the operator. The operator will observe your repository, will observe the changes to your repository, both the change related to the infrastructure and the application. Okay. The password is the name of the pod. This is a default configuration. Okay. Now I am into Argo CD. I can create a new app. There are a few settings that I have to type, such as the app name, the sync policy. I can have a fully automated pipeline, or I can have a manual pipeline. This means that I have to trigger the deployment. The repository URL okay. And then I have to go the path of the configuration files. In this case, I will set the dev environment as a configuration file. Then I can select the cluster, the target cluster, and the namespace. I will create a new namespace. Of course, I need to create the namespace on the cluster. So once I have created the application into Argo CD, I can check the state of the application. Right now it's out of sync because I have not yet applied the configuration to the cluster. So there is no deployment yet. I can do a sync. This means that Argo will observe the repository and then will update the Kubernetes cluster with the configuration and the application. Now I have an error because I don't have the namespace yet. I have to create the namespace on the cluster. I can do that using kubectl. If I sync again, Argo is taking care of deploying my application. And I have monitoring out of box. So I can understand if there is a case of divergence between the actual state of my system and the desired state. Let's see how I can update the application. For example, I add a new version of my application. Okay. I will just set a new image, a new tag on the image. This image is on Docker Hub, but the problem is that I don't have a version 2 of my application. So let's check if Argo will alert me of the missing image. Okay. I'm just updating customize. Yeah, that's okay. I will do a git push. In a few moments, Argo will check the repository and will alert me that there is a not synced change. I can do also a refresh out of sync. So this means that on the repository there is something new that I have to deploy. Now, if I deploy the new image, the new configuration, I will have a problem because the new image doesn't exist. And sorry?
How we can see that there's a problem because it's actually saying OK on the dashboard.
It's okay from here. When you have an alert, it means that there is a problem. And you can have a degraded state of your system. You can go into events. You can check the state of the pods and the deployment. In this case, there is no image. So I will check I will have the error about the image not found. You can have also logs. You can also check the differences between the side state and the actual state. Because if you go to, if you go to the pod, here you can find the live manifest, the one that you have applied to the cluster. And thanks to kubediff that is that is used inside Argo, you can check also the differences between the new configuration. And what you can do in this case is just a revert. You can revert the commit. So in case of meltdown, if you know that, for example, the last commit is the problem, you can revert the last commit. I will do that. And then I will push the change to my repository. Okay. I will do a refresh. And then I will have another out of sync. Now if I apply a sync operation, I will synchronize the configuration, then my pod will come back again. It will work again. And how Argo will check the status of your pod? Argo have some check status that you can set, and you can also write your own check status. And if there is something that it's not working, Argo will say to you that the pod has a degraded state. And this is interesting because you have everything in one tool. You have pipeline, you have observability, and of course you have also control. Because instead of divergence, you can also go here and you can apply or roll back the changes of your infrastructure and of your application. Okay, any question? Okay. So, is it GitOps the right approach for me? The answer is always the same, and it depends. It depends on many things, because if you have a cloud-native application, if you are using Kubernetes, GitOps will accelerate your software development process. And it's really simple to apply this approach to your software development process. You just need to adjust the name of your branches to put something such as Argo CD app. And it has a different approach between the classic that is build once and deploy everywhere, where you build one artifact and then deploy the same artifact to all your environments, just changing the configuration. It has a really low learning curve because you just have to know Git and few tools related to the continuous deployment pipeline, such as Azure DevOps or even Argo CD. And I found really easy to create a continuous deployment pipeline with these tools. With some customers, we have done the second approach, that is the use of the environments in Azure DevOps and using the Azure monitors to monitor the cluster state. But there are a few tools that you can use and are really simple to configure and to put in place. So that's all I have for today. I want to thank you for your patience. I want to know if do you have any question or even thoughts about it? What do you think about this new approach of deployments? Yeah.
Can you expand a bit on the differences between Azure pipelines and Argo CD?
Yeah, the difference is that in Azure pipeline, you don't have a real-time monitoring of your cluster. When you trigger the release, you just have the state at the end of the release. If your build or release have succeeded. With Argo CD, you have a real-time monitoring of your system because the operator inside the Kubernetes cluster will check once in a while the desired state in your Git repository and the actual state on your Kubernetes cluster. So in case of divergence, the Argo CD operator will update a new deploy trying to fix the problem. This approach is not implemented in Azure pipeline, so you have to check the state of your application with some tools such as Prometheus or Grafana, and then you have to apply a new deployment to fix the problem on your cluster.
Can I ask you a question on this? Because, to the best of my knowledge, actually application insights have been developed to address this like monitoring question, and they also feedback telemetry to Azure pipeline, so you can basically revert your deployment based on this telemetry.
Yeah.
So it means that this would be done both ways.
Yeah, of course, yeah. And the example here is based on Kubernetes, but you can also apply the same approach using, for example, app services. For example, you can use app services that are configured using, I don't know, Terraform. And then you can also do a check of the deployments using application insight. You can also use the deployment slot in app service to improve the way you are doing a rollback of your environments.
Assuming Argo CD has to run as a privileged user to do a deployment.
Well, when you have Argo CD put in place in your cluster, you just have the rollback access. You can have the rollback access applied, but you don't have any more access to apply, sorry.
So that's just scoping the access feed to the repository, right?
Oh, yeah, of course you have to access to the repository, but that's all. You don't.
Just observing is actually making state change on your repository.
Well, you have a read-only access to your repository. Let me go back to a slide.
I'll have a look.
Actually, you have a read-only access to your repository. Argo, for example, doesn't make changes to your repository. It's
a local state change, so it can roll back to a previous deployment, but it's localized within.
yeah, exactly.
So it keeps those versions.
Yeah, he will use kubediff, for example, to understand. Kubediff is a tool in Kubernetes that allow you to show the differences between two deployments. And then you have the differences between the two deployments, and he will know if you have to do a rollback or what changes.
It's not doing a git revert, it's doing a revert within its own localized deployment history.
Yeah.
Okay, got it.
Yeah.
Okay,
Any more questions?
So on Argo CD screen, it wasn't actually shown which environment was it? Because the environment is mapped to the brand, right? It wasn't actually showing whether it was dev or production. I didn't see, or you didn't zoom in. Because just my environment.
I'm sorry, can you repeat, please? Because I think I have it to you.
Name on Argo CD screen?
The environment name on the Argo CD,
I just didn't see it on the screen.
I didn't see.
It was the deployment, but when Argo CD was deploying and was actually doing the sync, which environment was it?
Oh, okay. It's do you mean the cluster where I deployed? Okay. I deployed on the Docker for desktop on my machine, and the namespace is Argo CD deployments, the namespace that I have created before.
So in real life environment, you will have your dev, production, UAT for the namespace.
Yeah, yeah. But you can also have multiple clusters with different namespaces related to your environment. Okay. The only thing that you have to put in place few operators on different clusters, and then observe the repository from each cluster.
Thank you.
Thank you.
Thank you very much, everybody, for coming. We're arranging a meetup in April, so stay tuned on the meetup webpage. Cheers. Thank you.